Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. I am going to explain on the example 1 on chapter 5 part 1. There's a little bit of confusion previously, so I'm going to uh, explain to you a bit of some of correction, and then we'll go into second example to show you a bit more on this part. Okay, so previously in chapter 5 part 1 we focused mainly on finding the modes or determining the modes for a 2 degree of freedom vibration, right? Now so in this example, the one that we have done before, so we have these two masses, which is basically um, uh, representing a building, a two-story building. So previously in the example that I've shown you during the live session, is that I think the mix up happened when I put where we have the spring and mass, and I think I put M1 in the middle instead of M2 in the middle, because in this example the M2 is in the middle and M1 is at the end. So that's the mix up. So here I'm going to just show you in terms of the side to side movement or motion, which is basically the same as the simple mass and spring system. So we have K1 X1, basically the one in the opposite direction, and K1 X2. In M2 we have K2 X2, K1 X2, and the positive side is K1 X1. Okay, now in terms of the equation of motion, so we start off with the equation of motion. I think you all should have mastered this how to derive equation of motion already. So we can have the first equation of motion and the second equation of motion. So this one minus over here basically equals to the minus direction for these three spring forces. So the one K1 X1, K1 X2 over here and K1 X1 over here is the positive ones. So if we were to derive in terms of matrix form, so we have M1, M2 over here, K over here. Okay, so if we rearrange everything and we bring this one on the right side towards the left side, so that's why we have these matrices. Okay, and if we consider it is a harmonic input or harmonic vibration, and we consider this part over here and we take it the determinant for it to find the characteristic equation. So we have already substituted omega or x with u cosine omega t into the equation, and here it left with m and omega. So we bring this and we continue with the characteristic equation and we find the roots for it. So if you can see here, the roots basically 3 plus minus square root of 5. So this part over here, so if you still remember, to find the roots is minus something, plus minus square root over 5, right? So since here is already minus, so minus is gone there, right? So it's 3 plus minus. So if you can see here, we have plus and minus. So we separate that one, and one is plus, another one is minus. So basically the sequence is this plus is the first mode and then minus is the second mode. Okay, so when we do with the first mode, we'll get 1.618. Second mode is 0.618. Now we assume that the max amplitude of x2, okay, x2, remember x2 is in the middle, right? So x2 is 1. So if you can see here, the coordinate, or basically the mode will be 1. We take the first mode, so 1.618 to what? the second mode, here it's negative 0.61821. Now, why is it negative since over here it's positive? So we'll see over here. So down here we can say that the first mode, so it will start from the bottom, right? So the building will spring from the bottom. So the first mode, you can see here, you have one node and basically one antinode, right? So if you remember, the first mode will like just one wave, right? So one node, and basically sorry, one antinode and two nodes, right? So if the variation is like that, okay. So so we can say 1 is the maximum for x2, right? So then x1 is 1.618. So we can draw our mode shape like that. Okay. For the second mode, we should have basically one sort of like one and nodes over here, and antinode over here, and nodes, or basically two of four nodes. So the vibration will be as I've shown before. I think we have the diagram over here. Let's see. Okay, over here. So for the second mode, we should have a 3 nodes and 2 antinodes. So sort of like you need to have 2 peaks, right? 2 peaks. Okay, so basically this represents one peak, and this is going to be towards the second peak. Okay, so since it is 2 peaks, so this should, from 1 is the fixed one, right? X2 is equals to 1, and then the second peak should go towards the negative part, right? So that's why we consider over here it's negative 0.618, so that the next peak is going towards the negative part, so you will have a second mode vibration. Okay, now so basically this is how you draw the mode shape. Now we go into the second example. So this one is basically the simple system, similar system as previously, but now you have 3 springs, okay, and each of K1 and K2 is fixed. So we determine our equation of motion. So this one, as I said, you should be able to master already. So we proceed immediately with the matrices, okay? And for harmonic vibration, we consider x1 and x2 as capital X1 cosine omega t plus phi, which is the phase, and the second one as follow, right? So if we substitute 2 and 3 into equation 1, so basically we'll have this kind of shape, okay? So and then we need to find our characteristic equation. Okay, so we find our characteristic equation by finding the determinant. Okay, now let's say this is just to make it very simple. So let's say that m2 is equals to 2m1 and k1 is equals to k2 equals to k3. So basically we have k, same k, and m2 is equals to 2 times of m1. And we assume that our assumption over here is the maximum amplitude for x1 is 1. So remember, x1 is where? X1 is over at the top. Okay. Now, since we have this assumption over here, so we can say m1 is equals to half of m2, right? Is equals to m. So we take one variable over here, and k1, k2, k3 is equals to k. So we make it everything simple. So if we substitute everything to make everything as m and make everything as k, so we substitute everything in the characteristic equation, and we find the roots. So basically we'll have these roots over here, 3 plus minus square root of 3 over 2. Okay, so we find the roots. So the first root will be 1.538 and the second is 0.796. So we take those two values the same way as we did before. Now the first mode, again the first mode, since our we can either start from anywhere from top here or from the bottom. Basically both are fixed, so there's no reference point or which you should start from 0. So the first mode is we can take, for example, we already determined the maximum amplitude for x1 is 1, so we can draw from the fixed point towards 1, right? And then first mode is 1.538, so you can go up here 1.538 and back to the bottom 0. So here it's sort of like one wave shape, right? Okay, so that is for the first mode. For the second mode, again from 0 to 1 for x1, and again this one over here is positive, right? But since second mode is it has two peaks, right? So from 1 towards negative 0.796 for the second peak, back towards 0. Okay, so that is how we draw the first mode and then the second mode. Okay, so that's it. I hope this should suffice. Oh, and I forgot, in the harmonic vibration here we have phi, right? I'm not sure whether I have explained to you before or not, but since we basically start off and since there is no particular condition, initial condition, to where the displacement should start, so we consider everything the displacement, meaning the motion starts from 0. So meaning motion starts from rest. So from rest and then certain displacement. So if it starts from rest or start from 0, then our phase basically becomes 0. Okay, our phase becomes 0. So then we can get rid of this and left with omega t. That's why in the first example we have only cosine omega t, because we consider it to start from rest. Okay, so that's it. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.